All right, here is some help with how to solve exponential functions with logarithms, specifically common logarithms, but that's all you're going to be introduced to in this class. Um, so the biggest deal right now initially is to solve for 10 to whatever the exponents are, which means get them by themselves. Okay? Get them by themselves. AKA everything else has to be on the other side. Okay, so I want to get this by itself. How do I know what to do first? Get rid of the 2 or the 4?
With the orders of operation, that's the right two first, right?
Okay, so when we solve, you're right that that's how you do it if you compute, if you're computing an answer. But when you solve, you follow reverse order of operations, okay? So since we're going to do reverse, we have to get rid of the positive 4. How do I get rid of the positive 4? Subtract 4. Okay. All right, so I have 2,000 here on the right, and 2 times 10 to the power of x plus 3. Okay, so Elena, how do I get rid of the 2? Divide. Okay, whatever I do to one side, must do to the other. Okay, so I have 2 times and 2 divided, so those simplify out. 2,000 divided by 2 would give me 1,000. And I have 10 to the x plus 3 power isolated. So that's the first thing you got to do. Get 10 to whatever power it is by itself. Here's where the new concepts come in. Okay? So when I have this, I can use a logarithm. Okay? And just like subtraction undoes addition and division undoes multiplication, a logarithm is what undoes this 10, okay? Algebraically speaking, it's what simplifies out that 10. Okay, so if I apply a logarithm to both sides, I'm taking the log of 10 to the x plus 3 power and the log of 1,000. So normal rules apply. Whatever I do to one side, I must do to the other. All right, so the log of 1,000, it's asking 10 to what power is 1,000? 10 to the third power. So I can replace that with 3. And log to the 10x plus 3, I told you that the log and the base are what simplify out. So the log and the 10 simplify out, leaving me with x plus 3. Here's why that works. If you put this in your calculator. Oh, here, I'll finish this. How do you solve this right here? Subtract 3. And you're left with x equals 0. All right, here's why that works. I want you to have a calculator in front of you, so go grab a calculator now. And I want you to put log of 10 to the third power in your calculator. What do you get?
3.
3. Is that what you got to, Elena? Bring it over here. Okay, so your log button is going to be right here. And then I'll put 10. And then that's how I deal with the exponent to the third power. Now, I'm up in the exponent, so I have to get down by pressing the arrow button. And now I can close that parentheses. If you press enter, boom, 3. Okay, so what I want this to illustrate. A log is wanting you to think exponentially. When you put the log of a number in a calculator, it's saying 10 to what power gives me this number? Well, this is a self-fulfilling prophecy. We know that 10 to the third power is our number, right? So 10 to what power is this number? Well, 10 to the third power is that number. Does that make sense? It's weird, I know. Okay, so here what I want to write down is that logarithms work as a way to undo base 10, at least algebraically speaking, so that we can work directly with the exponents. Okay, it's just another tool we can use to solve. So when you're solving, this is more of an overview. You have your order of operations. This is the order you have to follow in to solve. So speaking in this order, if I have a subtraction, what do I have to do to undo subtraction? I have to add. What do I have to do to undo addition? I have to subtract. What do I have to undo to, or how do I undo division? Multiply. And how do I undo multiplication? Divide. Okay, so when I'm trying to get exponents, it's undoing a base. But when you think, how do I get exponents down? I want you to think we're dealing with logarithms. All right? And just a reminder, parentheses is not an operation. It's telling you you have to do that operation first. Yeah. It's just giving order of importance.